This is the MDN documentation page for the JavaScript array. And look at how many instance methods we have on here. There's a lot, right? Once you declare an array in JavaScript, there's a ton of different operations that you can perform on it to get what you need to get done. In today's video, we're going to take a look at some of these array methods, and I'll show you how they work by deconstructing them and demonstrating how you might achieve the same results as these methods with a for loop or other procedural code. Right, we aren't going to have time to go over every single JavaScript array method in this video. So in order to pick out some of the more interesting ones, I'm going to divide these methods into two categories. There's going to be projections and mutations, otherwise known as immutable functions and mutable functions. But I'm going to call these projections and mutations because I think these words better describe what's actually happening with respect to an array. So firstly, a projection. A projection is a method that creates something new based on the data inside of a variable. So think of the bat symbol being projected into the sky. You take the template that Commissioner Gordon puts over the end of the searchlight, and when they switch it on, it projects that image of the bat symbol onto the clouds. You still with me? So an example of a projection would be x equals y plus 1. Here, the variable x is being assigned to the result of this projection of y. We don't modify y in this operation at all. We just use it to help us create x. The opposite of this is a mutation. A mutation is where we do modify the data stored in a variable. So we can do this either by calling a method on that object that causes some underlying value inside this to change, or by reassigning the variable. So whereas x equals y plus 1 is a projection, a mutation might be y equals y plus 1. Here this line of code actually changes the value of y. So array.push is a mutation, because when you call this, you're actually modifying the data inside this array. It's mutable, which means it can be mutated. So given these two types of operation, we can group this big long list of array methods into two categories: immutable projections and mutations. Here they are. You can see that array.push is on the left-hand side because it's a mutation, whereas toString, which is a function on most JavaScript options, that's on the right because toString projects the array into a new string. It doesn't modify the actual array at all. By the way, it is actually possible to test all of these. If you want to know if a certain method is performing mutation or not, then you can take advantage of strict mode and object.freeze. Performing these two steps will make this array variable immutable. So anything we do after that attempts to mutate the state of this array will fail. For example, if we were to call push on this array, you can see we get an error. Whereas if we did map, that's fine. So all of the methods on the left-hand column here will fail if we try to do them on a frozen array object. I'll definitely do a more in-depth video in the future about object.freeze in JavaScript. So if you think you'll be interested in that, then please don't forget to subscribe to this channel. Now let's get on and explain some of these array methods. And it's these immutable methods on the right-hand side that we're going to take a deeper look at in the rest of this video. There's been a definite trend in software engineering over the last few years to favour immutable objects, because it does generally make your code easier to rationalise and easier to read. So that's what we're going to focus on in here too. The first immutable projection method of an array that we're going to look at will be map. Map is a very simple function that projects your array into a new array of the same length, and it performs some kind of transformation on each element. I'll show you with an example. So here we have this array here, 1, 2, 3, 4, 5. We can call map on this array and pass a function in here. This tells us how to create the items of the new array. So in this case, we're going to have a new array where each item is multiplied by 2, n equals n times 2. We can run this in VS Code by just hitting F5 and choosing node, and you can see the output here is 2, 4, 6, 8, 10. Now what would we do if we didn't have this map function? Well, without map here, we'd have to loop through this array and perform the mapping on each item manually. So what I'm going to do is write out what this function does in here so we can get a better understanding of what's actually going on. So I'm going to create a function called equivalent function. And that's going to get my array passed in, I'll call it source. and the function that you use to map the array. So in this case, function, or fn, that will be this n to n times 2 function. So let's try and recreate the map function in here using just procedural logic so that we can really get an understanding of what it's doing. So the first thing we'll do is we'll create a result that is an array of the same size of the one that's been passed in. Oops, didn't need that. And then we'll do a for loop. So most of the functions that we're going to look at today are going to be for loops under the hood. So let's just do a for loop with an index of I, which is 0. We'll keep on going until I is source.length, and then we'll increment it each time. And then in the result, at the index I, we're going to run this function on whatever is passed in at index I. So this is our map, basically. This is saying that for each element on the array, we want to run the mapping function, take the result of that mapping function, and copy it into our result. And then we return result. So this function now, this equivalent function, this should be the same as a map. We can test this out if we do result equals that, and then pass in the array and do our same n times 2 function in here. So this result variable should be the same as the result that we got before. So let's just test that out and see if it logs the same as the one above it. I'm just going to put a breakpoint in here. Yep, there we go. So the second one has logs 2, 4, 6, 8, 10 as well. So this equivalent function has done the same as the map. So you can see we're looping through here, and for each item, for each index, we're executing the map function and assigning the result to the result of that map function. So that's map. Now the next function we're going to look at is going to be the filter function. So filter in JavaScript is a way to take a large array and project that into a smaller array. And you give it a function which tells it which items to keep and which ones to filter out. So the function will return either true or false, and there's a special name in programming for a function that returns true or false, and that word is predicate. So back to the code. Here is our familiar array of numbers from 1 to 5 again, and then here is the array with the filter applied. So the predicate in this case is using the modulo operator to say, is this item divisible by 2? So is n modulo 2 equals 0 basically? That's what that means. It's saying, is it divisible by 2? So result here should be the items in the original array that are divisible by 2. So let's just run this and we can see what we get back. There we go. 2, 4 is what's been printed out into the console. So it's run this predicate on every item inside the array A, and it's only returned the ones that are divisible by 2. So just like we did with map, let's go in and see if we can build a new version of this that doesn't use the filter function and just uses a loop, because this is where we're really going to understand what's actually going on, okay? So equivalent function again, oh look at those. We'll pass in the source array and we'll pass in a predicate. A predicate, remember, being the function that returns true or false. I'll have a result variable just like before. This time it's going to be dynamically sized because we don't know how many results we're going to return. We're not, unlike map, where we always return the same number of results as we had at the start, filter could return any number as long as it's underneath the one we had before. We'll create our loop again, I equals 0, I is less than source.length. And then here we're going to do an if statement. We're going to say if the predicate of the item at position I, if that is true, so I can just leave it inside the if that is true, then add it into the result. So result.push source I. If it's not true, then it doesn't go into the resulting array and it's not going to be returned. So we should be able to return just the items for which the predicate is true. So this equivalent function should basically be the same as the filter function in JavaScript now. Let's just put it into the result and see. So we'll put A, and then we'll put, what did we say, n modulo 2 equals 0. And log the result out there, and you can see the result of the second function is the same. It's 2, 4, the same as the filter function. So that's been our filter function. Next we're going to look at a function called sum. Alright, the next function that we're going to look at is called sum. Up until now, all of our array functions have been returning another array. Sum is a function that returns true or false. You give it a predicate, just like in filter, as we've just seen, but instead of returning a filtered array, the sum function will return true if any item in the array returns true from the predicate. So here's a sum function in action. Our predicate here is this n triple equals 3, and this will return true if the source array has the number 3 in it, and it will return false if it doesn't. So let's test this out. We can run this, and we should see our result to be true because the source array has 3 in it. There we go. So we're getting true printed out. We can type this out like we've done with the others. We can create an equivalent function, and again this will be a so just like all the others, we'll create a loop for I is 0, I is less than source.length, and then increment I. And just like the filter function, we can do an if statement in here that runs this function that you've passed in on the element I, and if it's true, we just return true straight away from the function. So we're sort of shortcutting the rest of this loop, and if none of them are true, then we'll return false. So here, this equivalent function, this is what sum's doing. Sum's looping through them all, running your predicate function. The predicate, remember, returns true or false. And if that returns true, then our sum function returns true. So we can run this on the result, and we should find that it says the same as the last one. All right. There we go. That's returned true as well because our array does contain the number 3. Right, find. Find is the next function on our list, and find is actually very similar to the sum function that we've just looked at. The only difference is that instead of returning true or false if an item exists, find will actually return that item. So you give it a predicate, again, I've put in n equals 3 like last time, and if there is a number 3, this will actually return the number 3. So if there's no item that matches the expression, then the find function will return undefined. So again, we can write this out, and it will be very, very similar to last time. In fact, I might just go back to sum and copy this equivalent function here. But this time, instead of returning true, we return the item that we found. So that will be returning 3 in our case. Otherwise, we return undefined. Okay, and then we'll put result equals equivalent function just to test this out. And let's run this, and we should find that just like with the others, we should find that this actually returns the number 3 now. Here we go, number 3 was returned just like the first time. So that's the find function. The find function, as we said, is fairly similar to sum, but instead of returning with true or false, it returns the number that's in it. Next up, we have slice. If you've done any Python or Go programming in the past, you'll already be familiar with this concept of taking a slice of an array. But essentially what this function is doing is it's extracting a block of items from a longer array and returning those as a new array. So here, by saying slice 2, we're getting our new array from our 1, 2, 3, 4, 5 source that starts from item at index 2. Item at index 2, remember, is the third item in the array. So in this case, the result of this operation will be a new array containing the last 3 numbers. That's 3, 4, 5. None of these functions will modify the underlying array, remember? So we aren't removing anything from this source array by doing this. We're just creating a new array with these 3 elements. We can run this, and we should see it say 3, 4, 5 because that's what we're taking. Here we go. In the console at the bottom here, we've got 3, 4, 5. So again, let's try and see if we can write an equivalent function. I'm going to pass in this from variable. This will be the number, the index that you want to go from. So in our case up here, we've been passing in 2. And the resulting array size is going to be the size of the original array minus that index that you're passing in. So up here, for example, it will be the size, which is 5, minus 2, which is where we start from. So we'll have a resulting array of size 3. And then we can do a loop, just like always. So here you can see we're looping through, and in the resulting array, so we'll be minusing from, so we'll start from say number 3, and then we'll do 3 minus 3, which will be 0, and then we're copying in the source array into that. So this is going to be the equivalent of our slice function. Let's just put this into the result and see if it works. Pass in the A, and then we'll say that we want it from number 2. Again, the code for all of this will be on the Train to Code GitHub repository. So for this, I'm actually going to step through this function with the debugger so you can get a better idea of what it's doing. So the first thing it does is it creates a new array of size 3. So you can see our source is an array of 5 elements and our from is the number 2. So we create that, and then we start to loop through here. Debugging is really useful to really work out what's going on with some of this stuff. So I'm just using Node.js and Visual Studio Code. And you can see that I starts at 0, and we're going to say I minus from is going to be source. I actually shouldn't start at 0 there, should it? It should start at from. So I've got something wrong there. There we go. Let's try this again, and I is going to start from. There we go. So it printed out 3, 4, 5 by assigning the subarray inside a result. Okay, next up is concat. Concat is short for concatenate, which is a fairly obscure word that means to link things together. You might have heard of string concatenation like this. That means to create a new string by linking together smaller individual strings. Well, arrays can be concatenated too, and in JavaScript you do that with the concat function. Concat takes in another array as its argument, like this, 6, 7, 8. And then it constructs a new array from all of the items in the original array, and then it appends all of the items in the array that you've passed into the function here. So the result of this will be 1, 2, 3, 4, 5, and then 6, 7, 8, all in one long array. So let's try and deconstruct this like we've done with all the others. Now this time we're going to need 2 for loops, because we're going to need to copy everything from the source and then copy everything from the other array and return the result. So we'll create a result which is a new array of size source.length plus other array.length. Might have plus about length, right? I missed TypeScript. So we're copying everything from the source array into our result, and then after that we're going to start copying everything from the other array into our result as well. So we do I again, and I is less than other array dot length, and then increment I. Results. Okay, so by doing these 2 for loops, we've copied everything from the first array and then everything from the second array. So if we run this on our function, we should, just like before, we should get 1, 2, 3, 4, 5, 6, 7, 8. Right, I've left the most complicated array method until last, and that's reduce. Reduce is the array method that people seem to be the most scared of because it is a bit difficult to read exactly what's happening sometimes. So I'm hoping that by doing the deconstruction on this one too, we'll be able to shine some light into what this function is actually doing. So let's start with the name. The word reduce means to take something big and to make it smaller. And that's exactly what reduce function in JavaScript is doing to your array. What it does is it creates an object in memory that it calls an accumulator. and then it loops through each element in your array, letting you write a function to describe how to add to that accumulator or how to modify that accumulator. So like here, I've got a really simple example of a reduce function. This is the same source array that we've been using for all of these methods, so that's 1, 2, 3, 4, 5. And the reduce function here is simply adding them all together. This function with the two arguments, accumulator and item, you might see these called previous and current in the docs, but they do the same thing. This accumulator parameter here, this is the result that we're building up with each iteration of our loop. And then this is called for each item in the array, so this is the individual items. The last argument here is the starting value. So we're going to start from 0, and then for each item we're going to add the value of the item to the accumulator. The result of this function will be all of the items in our numeric array added together. So we can run this, and we should be able to get whatever the result of 1, 2, 3, 4, 5 added together is, which is 15. Okay? So let's go about creating an equivalent function for this. And I will show you exactly how we can do this reduce function with procedural logic, okay? So we'll take the source, we'll take the function, and then we'll take the initial value. And then we'll have a result, which is an accumulator, and we're going to initialize that to the initial value. So in our example above, the initial value is 0, and so the result starts as 0. And then what we do is we loop through our source array. And for each item in the source array, we're going to reassign the result with the result of the function saying pass the result into the first argument, if that makes sense. So we're going to execute our function with the result passed in as the accumulator. So for example here, we're saying pass in the result, pass in accumulator, and then also pass in the item that we're on. And whatever we get back, that's the new version of the accumulator. And we can return result. So again, I think it might be helpful if I actually step through this in the debugger to show you what's going on. So we'll start with this. We'll say, I'm just going to call this A and I, but this will be accumulator and item. So A plus I, and then start with 0. So we're going to start the result as 0, which was this initial value that was passed in. So that's going to get assigned to result. And then we're going to loop through every item in the array. We're going to pass in the accumulator, which is currently 0, and the current value of the source. So that'll be 1 the first time. That will execute the function, and that will update the result. So the result is now 1. We'll do that again, and that should add in the second item. So the result should now be 3. So 1 plus 2. Is that right? Yeah, that's 3. And then we'll add it again, and that should be 1 plus 2 plus 3, which is 6. Add it again, add it again, add it again, and then return the accumulator. So the accumulator result at the end will be all of the numbers added together, which in our case is 15, which is exactly the same as the value that we got when we ran array.reduce. So by doing this, we've implemented the reduce function ourselves. Cool. Array manipulation is something that really is at the very heart of software engineering. It doesn't matter if you're doing front end or back end or DevOps or test automation, you will need to be able to comfortably work with arrays. This table shows how array manipulation in JavaScript has evolved over the years. The methods on the right here that we've looked at today are generally newer than the ones on the left, and that's because of this shift towards immutable functions that we spoke about earlier. So I hope these explanations have given you a bit more of an insight into what some of these array methods are actually doing, and have given you the tools you need to be able to go out and write code using functions yourself. If you go to the Train to Code GitHub, and under the video examples, I'll upload the source code to all of those deconstructed functions that I wrote. So go and have a play around with that. There'll be a link to the GitHub repository in the description of this video as well. Also, don't forget to subscribe to this channel for more coding tips, for more project, exercise, and general software engineering chat. My name's James Charlesworth, and I'll hopefully see you in the next video.